We're going to begin our equations unit by drawing some absolutely beautiful pictures. This means that this video is going to be the most helpful tool to solving the hands-on equations, because I'm going to be honest with you, your people at home that are used to helping you with math are going to have no clue what these things are. And there's not a lot of information out there for non-teachers regarding hands-on equations. So here is the purpose of hands-on equations. Hands-on equations are designed to take this abstract idea of equations and make it concrete. Since the goal of an equation is to keep both sides balanced, we use a balance beam to represent this. And you'll notice that there is the balance beam. So our goal is to keep this side equal to this side. Okay? Now, while equations can use any variable, hands-on equations uses just the variable x, nothing else. And we represent the x by using a blue pawn, which we use in a drawing called like a blue triangle. So if we had 2 x's, that would be 2 blue triangles. If we had 5 x's, that would be 5 blue triangles, and so on. Now, you all know we wouldn't be just living in the land of the positive. We would be entering opposites and negatives, and we would show this by using what's called a star. So star just means opposite of x, okay? Because notice I didn't say that one was positive or one was negative. I simply said opposite. We will get into that in a little bit, but just note that an x and a star are total opposites. One is not always the positive version, one is not always the negative version. One of them will be positive and one of them will be negative. It won't always be the same one, but they will be opposite each other. And we use a white pawn, and to show that in a drawing, we draw a triangle that's empty. Constants are the numbers in an equation that don't have a variable. And we're going to represent those with number cubes. Now, the cubes only have digits 1 through 10 on them. When you actually use the hands-on equations kit, you end up with 8 blue pawns, 8 white pawns, and then that you have 4 dice. 2 of them go 0 to 5, and 2 of them go 6 to 10. So, and then we use addition to total up the constant for the problem, meaning that we won't go outside. If it's a number of 20, we would have 2 10s to represent that, because 10 plus 10 is 20. Or we could have 4 5s to represent that, because 5 plus 5 plus 5 plus 5 is 20, and so on. Now, we show this by drawing a white square or square and an empty, and then we write the number inside of it. And I was misspoken when I talked about the dice, or the number cubes. 0 through 6 are on 2 of them, and 5 through 10 are on 2 of them. Sorry, I misspoke about that. We will always check our answers by substituting in our answer for x. And then we use order of operations to solve, because all we're doing is checking, is the answer I have for x, is that going to solve our equation? Now that you've heard all of the background, let's try and put this into context. So take a look at the first problem. Now, I'm hoping that yours are going to look a lot prettier than mine, because I'm having to freehand this on here. So again, hopefully yours look a little prettier than mine. Now, we're first asked to do x plus 2 plus 4x equals 27. We show this by drawing x plus 2, and remember we draw a number cube and put a 2 in it, plus 4x. And it's going to equal 27. Now, if we were using the number cubes, we would add up all the way to 27. However, for drawing purposes, I can make 27 by showing a 2 plus 25, because 2 plus 25 represents 27. So on the right, that is not 225. That is 2 plus 25, and that equals 27. Now, in an equation, it's all about keeping things balanced. We want both sides to equal the same thing. In order to show that they equal the same thing, the first thing we have to do is we need to get all the triangles by themselves. We don't want anything else with them. They're kind of this like group where they're a super tight group of friends and they don't want any new people joining their tight group of friends. It's a very middle school idea. So we're going to take away this 2. They said, we're going to take you away. Now, by taking away 2 from that side, to keep it equal, we must do it to both sides. Okay, and let me kind of give you a random example to show you why. If I've got 5 equals 4 plus 1. If I come in and add 1 to both sides, it's still equal. If I come in and I take away 4 from both sides, they're going to be equal. As long as you do it to both sides, you can pretty much add or subtract anything you want. So in this case, I took away 2. Well, that means that I'm now left with 5 triangles and it equals 25. So let's think this through. If 5 triangles equal 25, what number could I put in for x to equal, what number could each of those triangles represent? If we were to check it out with a 1, 1, 2, 3, 4, 5, could each blue triangle be 1? No, because if we add up all those 1s, we end up with only 5. Could each of them be 2? 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. Nope, that doesn't equal 25. What about 3? 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. Nope, doesn't work. Let's try 4. 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. Almost. Now let's try out 5. 5 plus 5 is 10, plus 5 is 15, plus 5 is 20, plus 5 is 25. So we now know that x has to be 5, because in order for each blue pawn to equal 20, each blue pawn, if we add them up, it needs to equal 25, and both of them do. To check our answers, I've kind of given it to you already, and I just wanted you to see it to get an idea, because without actually having the pawns or seeing someone in front of you explain this, it's a little bit more difficult, so we wrote a little bit more here. But to check our answer, what that means is every time in our first beginning setup, that means we are checking right here, this step, not below it, but above it, what we drew first. First we had x, and we know x to be 5, and then we added 2, and then we added 4 more 5s. And we want to know if we add up both sides, do they equal each other? And we added 2 plus 25. So what we'll do is we'll actually go through the process of 5 plus 2 is 7, plus 5 is 12, plus 5 is 17, plus 5 is 22, plus 5 is 27. So we have a value of 27 on that side. And then on the right, we have 2 plus 25, which is 27. So our answer makes sense. For anybody who's really nervous about math and gets kind of anxious about, is my answer the right one? Did I get the right one? This is a great, great thing to have because it allows you to check your answers. So that is example number 1. Now that you've seen it, hopefully you have a bit of an idea for it. So now let's try a slightly more complex one. Example number 2 says 2 parentheses 4x plus 1. Now, hopefully at this point you're looking at this going, hey, I know that's the distributive property. But we're not going to distribute in this case. What we're going to do is we're going to draw 4x plus 1. 1, 2, 3, 4x plus 1. The 2 says do this 2 times. So it wants you to represent what's in the parentheses 2 times. So there, I did it 2 times. Now, when I go to build 18, I know I want to start with what I have on the other side, which is 1 plus 1, and then I have 16 more. Now, our goal is to get all those blue guys by themselves. Remember, they don't want to play with anybody else. They don't want anybody part of their friends. So we're going to take away a 1 from each side, and then I want to do it again, because I can actually take away 2 1s from both sides. And what are we left with? Well, we have 1, 2, 3, 4, 5, 6, 7, 8 triangles, and we know it's got to equal 16. So you can go through the process of guess and check like we did above, or you can look at it and say, because I know there are some of you who are smart and are looking at this going, hey, I know that each one needs to be 2. And the reason that we know that each one needs to be 2 is because 2 plus 2 plus 2 plus 1 plus, now that's what represents the 4x plus 1, is 4 x's plus 1. And then we do it a second time, 2 plus 2 plus 2 plus 1. And then we said that it would equal, because remember the check is going back to how we set up the problem in the beginning, that it would equal 1 plus 16. So we have that 2 plus 2 is 4, plus 2 is 6, plus 1 is 7, plus 2 is 9, plus 2 is 11, plus 2 is 13, plus, did I miss one? Oh, I forgot I didn't do enough 2's. Whoops. Plus 2. Plus 2. Okay, 2 plus 2 is 4. Let's try this again. That's why we check our answers, because it wasn't working out for me. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 1 is 9. Plus 2 is 11, plus 2 is 13, plus 2 is 15, plus 2 is 17, plus 1 is 18 on this side, on the left, equals 1 plus 1 is 2, plus 16 is 18. It works out, so we know our answer is right. Moving on to example 3. We have 2x plus 4 plus 2x equals x plus 20. All right, so we know how we're going to start. And I like how I drew those last triangles, so I'm going to do that again. So we have 2x plus x plus 4 plus 2x equals x plus 20. And we know we're going to make up 20 by using 4 and 16 because 4 plus 16 is 20. We can take away a 4 from each side. And now we have something else we can take away. Those blue ones, they're on both sides. Well, I want to get them so they're just on one side. So I'm going to take away a blue from this side, and I'm going to take away a blue from this side. This means that on the left, I have 1, 2, 3, 4. And on the right, all we have is a 16. So the question is, if 4 of those x's, 4 triangles, equals 16, how much does 1 equal? I say that one of them is 4, and here is why. We're going to check our answers. We are saying that 4 plus 4 plus 4 plus 4 plus 4 plus 4 equals 4 plus 4 plus 16. So let's check and see if we're right. 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20, plus 4 is 24, equals 4 plus 4 is 8, plus 16 is 24. So we find out that both sides, in fact, equal 24. Therefore, our answer of 4 is correct. Moving on to example 4. The 2x plus 1. Remember that means 2 times. So we're doing 2x plus 1 and we're going to do it twice. And then we have 3x, and it's got to equal plus 8, so we're going to make up 8 with 2 1s and a 6. Now look at what you have on both sides, because again, as long as we do it to both sides, all is well. I can take away a 1 from both sides. I can take away another 1 from both sides. Then I can take away a blue triangle from both sides, and a second blue triangle away from both sides, and a third blue triangle away from both sides. So what do we have? Well, on the left, the only thing without an arrow is one lonely blue triangle. And on the right, the only thing without an arrow is a 6. So this one's pretty easy to find out that one blue triangle is representative of 6. So x equals 6. Nice and easy. Let's go through the process of checking. We said 6 plus 6 plus 1 plus 6 plus 6 plus 1, because we did the 2x plus 1 twice, and it has to equal 3x, which is 6 plus 6 plus 6, plus 8. 6 plus 6 is 12, plus 1 is 13, plus 6 is 19, plus 6 is 25, plus 1 is 26. And now let's check the right. 6 plus 6 is 12, plus 6 is 18, plus 8 is 26. So we know that our answer of 6 is correct. Using hands-on equations is really, really helpful in making things a little bit clearer, especially because it's really hard to understand x sometimes. So this just, I think, helps make things a lot clearer for people. All right, so we've gone through x in a bunch of different situations, and these are not easy equations. So be proud of yourself if you're following along and you're understanding, you're doing well. This is what's called a star. It's basic, I know it kind of looks a little funny here, but that's what we're going to call them, is stars. So remember that stars are empty triangles. So we have 3 stars. 1, 2, 3. And immediately we are asked to take one away. So in order to show that this is a little bit different than doing the initial one, I start my arrow, instead of at the bottom, I start at the top, so it kind of goes all the way through to indicate, hey, let's take that triangle all the way. And then on the right, we have 1 triangle plus 9. So if we note, we have an empty triangle on both sides that we can take away. And what we are left with is that a yellow triangle is equal to 9. Or an empty triangle. In your paper, when you use the kits in class, it'll be white. But an empty triangle is 9. So we know that a star is equal to 9. Now remember, way back in the beginning, I said that star and x's are opposites. If it's opposite and a star is 9, that means by default x has to be -9. Okay, so in this example, x happened to be the negative. That may or may not be the case for the next one. Just know that once you find one of them, you'll know the other one because they're going to be opposites. Let's check our answers. So we have got, everywhere we see a star, we want to put in 9. We have 9 plus 9, because we know that the check is going back to this step. 9 plus 9. We had our 3 x's, but then we took one of them away. And then on the right, we have 9 plus 9. So let's check it. On the left, 9 plus 9 is 18, plus 9 is 27, take away 9 is 18, equals 9 plus 9 is 18. So we know our answer is correct. All right, the final example puts everything all together. Starting off, we have 5 x's. 1, 2, 3, 4, 5 x's. And it says take away 2 stars. Well, here's the problem with taking away 2 stars. We don't have 2 stars to take away. They're not there. Remember when we did integers and we were talking about 0 pairs? We can come in and add 0 to any equation. So the example of if I've got 5 equals 4 plus 1, I can come in and put plus 0. And 0 plus 5 is still 5. And 4 plus 1 is still 5. So even though I put plus 0, I could come in and say minus 0. And it's still going to equal the same thing. So whether you add 0 or minus 0, it's not going to change it. To show that we are adding a 0 pair, we draw an arrow from the top to drop it down, and we draw 1 triangle of each. And we need to take away 2 stars. In order to take away 2 stars, we have to add 2 zeros. So now that we've done that, we're going to take them away, and since we're doing it at the very start of the problem, the arrow for taking them away is going to start at the top of the triangles. We are then asked to take away 3 x's. So again, starting at the top of the triangles, take away 3 of your x's. Now we can finally go to the other side. We have 3 x's, 2, 3, plus 7, our one constant. All right, now let's take a look at what we have on both sides. We have 3 triangles. So, taking a look at this, what do we have on both sides? We have a blue triangle on the left, and what do we have on the right is we have a 7. So blue triangles are representative of x's. This means that x is 7. Now we have star. If x is positive 7, that means star has to be negative 7. Now we're in for a bit of a longer check just because of everything we did. I mean, take a look at your picture. If you can't look at your picture, look at my picture. It's kind of crazy having everything written like that. So to do the check, we're just going to move through this very slowly. We start with our 5 x's. We know x to be 7, so we have 7 plus 7 plus 7 plus 7 plus 7. And then we added those 0 pairs, which gave us those other 2 that we added. So we have plus 7 plus 7. And then we took away 3 of them. Minus 7, minus 7, minus 7. And then on the other side, we have 3 x's, 1, 2, 3. And then we have our constant of 7. So if you are wanting to go ahead and just make note that those 3 are going to be your 0 pairs because they kind of cancel out and there's just a lot to remember, feel free, because by circling it you're indicating, hey, I know that stuff. And when we check it on the left, we have 7 minus 7 is 0, plus 7 minus 7, which is 0, plus 7 minus 7, which is 0, plus 7, which is 7, plus 7, which is 14, plus 7 is 21, plus 7 is 28. And on the other side, we have 7 plus 7 is 14, plus 7 is 21, plus 7 is 28. So we know our answer is correct. Congratulations on completing Hands-On Equations notes.